Hey everybody, what's up? This is Cameron Snow with Danomics.com. In this video, I want to go over some of the ways that we can use machine learning within Danomics. So this is a question that I get all the time, which is, hey, AI and ML is a big priority of ours. What does Danomics do on that front? So the short answer is that, machine learning is available in a couple of different forms within the platform. A more detailed answer is that we give you the tools to build your machine learning and AI models on top of our data pipeline. So there's a lot of flexibility there, and kind of the sky's the limit. But I want to show you a couple of the built-in use cases that we have. So one of the what I think one of the most compelling use cases is one of the most simple, and this is the example of bad hole identification and repair. So when we look at well logs, we see there are places where we get washouts. So here we're looking at the caliper log in blue. We see that we have a few washout intervals in here that are affecting the bulk density reading. Of course, that's going to create problems for your porosity calculations. And as we get down in this well, we have a zone where we get a lot of instability, have a lot of washout in the well bore, and it actually affects both our density and our neutron in here. So what can Danomics do to help? Well, Danomics, one, we give you a number of criteria to flag washouts, but then just as importantly, we give you the ability to repair those washouts with multilinear regression and random forest models. So once you flag the washout, what the software will automatically do for you is it will construct every possible combination of model that is available to you based on your curve data, and it will flag that data if it's washed out, and it will, automatically apply that for you. And if you need to go in and do some adjustments on there, you can go do these zone by zone adjustments, and it will update that model on the fly. And you can see, it's repairing our density, our sonic log, our neutron in a couple of spots, really helping to clean up the answer. And this will prevent us from getting a few little erroneous porosity readings in here. And then once we go deeper down in the log down here to this zone, we can see that we are cleaning up a lot of spikes in here out of the density. These are unrealistic readings, and we're really cleaning this up quite a bit. So, it may not be a perfect repair, but it is a repair that's going to give us a chance of being able to salvage some of the data and interpretation over this interval. Okay, so that's one of the use cases is for curve, infill, and repair. Now, that's a pretty simple use case, and I think the simple use cases are the best. But one of the questions I get all the time, it's hey, I have gone through and I've done an interpretation of properties like my clay volume, TOC, and porosity in a limited number of wells, and then I want to apply that out to all the wells. How can Danomics help me do that? Okay, well, let me show you that. So here in this well, I've gone through and I've done just this. I've gone through and I've made interpretations of the clay volume in here. I've made interpretations of my TOC, so my total organic carbon calculations, made calculations of things like porosity as well. And I've got those mapped up here. So, here we've got our average porosity map, and we can see what we've got here. All right, so now let's say based on my interpretations in this well and a few of the others, I wanted to go through and build some machine learning models for that. So how can we do that in Danomics? Well, it's pretty straightforward actually. So here in Danomics, we have a toolkit called Flows, and I'm going to zoom in a little bit so you can see this a bit better. And what flows are, they're a bulk processing system that also allows us to call things like Python, so we can apply machine learning models using some of the familiar toolkits. And we've actually built in some tools for you, so you actually don't have to dip into the code at all. So here's what we're going to do is we're bringing in our logs. We are then uh, going to calculate a few curves. So, within Danomics, we handle, like I just showed you, the curve repair, but we also handle the curve aliasing, normalization, lots of different operations like that. And, as part of that, we create a new curve name. So, for example, gamma ray final, res D final, rho B final, and phi final. And then there are the curves that we've calculated, like TOC, porosity, and clay volume. So what we're going to do is we're going to generate those curves using the petrophysical interpretation that we generated here, okay? And then we are going to build those models. So we're going to build one model for clay volume. We're going to use a random forest method. Going to build another for TOC, and finally one for curve prediction. Now, once we've done that, we just hit the run button. This will start a job, and this will then calculate our models. And if we want to look at, how the models are performing, here it gives us the mean absolute error for our clay volume, our TOC, and our porosity calculation. So we can see we're getting very good uh, accuracies on those. Now, after we've ran this, it is going to create for us 3 models, and these are stored in these pickle files here. And then we come over here and we run the prediction. So once again, we bring in our log database. This time we're bringing in all the wells in our database and not just the ones we've interpreted. We are, bringing in the final curves from our petrophysical interpretation, because these are the ones that we want to use to make the predictions. And then we're predicting a V-clay from machine learning here using those curves and the model we trained in the previous step. We're doing the same for TOC and our total porosity. Finally, we're going to end this with a little bit of cleanup to get rid of these computed curves that we made here, and we're going to write that out to a new database. Once again, we hit run on this. This predict flow, it will tell us that, hey, it's made the predictions here. We can see that overall this process for around 60 logs only took around a minute and a half, so pretty quick. And then we bring that interpretation into a petrophysical interpretation. And what we can do is we can then go to our clay volume, and we can say, hey, we want to use our user calculated V clay for each of the zones. We're pointing it at this V clay from machine learning. We do the same thing for the TOC. We tell it we want to use a user curve. And when we do that, once again, we just point it at the machine learning curve. And we, once again, do the same thing where we apply this user curve, take the phi t from machine learning here. And when we do that, we can then come in and we can make our maps again and see how the results compare. So this is our average total porosity in the Niobrara Formation from the machine learning predictions. And let's just go back and forth between this map and our previous one here. So you can see, we have a bit of a high coming across to a low, bit of a high. Values here are just peaking up around 13 to 15%. Here around 11, 11.5, and we're around 8% in the middle. Let's look at that again. Coming up, 13 to 15% up here, 11 to 12% here, and around 8% in the middle. And we can look at this for the other properties that we predicted as well. So let's look at our average clay volume. Here we can see our average clay volume. We're going between 20 and around 35% as the high. If we look at it in this map, let's pop over here. Once again, once this map updates, we'll be able to see that, it's in a very similar range here. And that is an example of how we can use vClay to predict properties like, or how we can use machine learning to predict properties like our total organic carbon, our clay volume, and our porosity. All right, well, I hope that gives you a little bit of a taste on how you can use machine learning in Danomics. If you have any questions and you'd like to learn more, you can always reach out to us at sales@danomics.com. Thank you.